Your brain is a predictive engine. Right now, it is expecting the sound of breaking glass. It expects consequence. But what happens when reality drops a frame? But occasionally, the engine struggles to keep up. Everyone has experienced it. You drop a coin, a set of keys. You look down a fraction of a second later, and the space is just empty. We instantly blame our memory. We pace around the exact same enclosed room, trying to explain away a sudden void. We tell ourselves it bounced, it rolled away. We will do anything to avoid admitting what actually happened. In software design, when a server is overwhelmed, it executes a background protocol called entity culling. It quietly deletes minor physical objects from the environment to save memory and prevent a total system crash. We call it misplacing things. The system calls it optimization. There is a state called highway hypnosis. Your brain enters a low-power mode, executing repetitive tasks without conscious input. You arrive home, but you have no memory of the last 10 miles. You were physically present, but cognitively absent. When we see a person pacing on security footage, our brains try to solve it. We look for a destination in their behavior. When we don't see one, we feel unease. We label it a glitch, a loop, an error. Game developers use nav mesh to define where an AI agent can move. If the mesh is corrupted, the agent breaks. We do the same. We map our own lives in grids, daily commutes, routines, habits. We rarely deviate. We navigate our own invisible meshes. Is that person pacing because of a pathfinding error? Or is it just the most extreme version of the routine we all follow? We don't see NPCs in these recordings. We see a mirror of our own automated lives, caught in a frame we were never meant to analyze. If our automated lives are a mechanism to save cognitive energy, then the physical world must have its own methods of optimization. Every modern video game uses a process called occlusion culling. To keep the frame rate stable, the engine simply stops rendering objects that are hidden behind walls or lost in the fog. The mountain behind the fog doesn't exist until you clear the mist. The geometry behind a closed door is temporarily deleted. It's not a lie. It's a mathematical necessity to prevent a hardware crash. Throughout history, humanity has encountered this optimization in the physical world, but we gave it atmospheric names. We call it heavy fog. We call it a whiteout. We look at a horizon completely swallowed by mist and feel a strange, instinctual isolation. Your brain isn't just reacting to bad weather. It is reacting to a visual boundary, a drop in draw distance. What if the dense fog on a lonely highway isn't a meteorological event, but the reality engine forcing a temporary buffer zone because the environment ahead hasn't finished loading its assets? We accept the fog because science explains it. But we never ask why the world looks so terrifyingly empty when the visibility drops to zero. In computer science, a memory leak occurs when a program fails to release discarded memory. The system slows down, old data corrupts new inputs, and files begin to blend together. In human culture, we call this the Mandela effect. Millions of people sharing a precise, identical memory of a historical detail, a logo, or a timeline that never existed according to official records. Psychology dismisses this as collective confabulation, a simple glitch in human software, where our brains rewrite past data to fit a narrative. But let's look at it from a structural perspective. When a global server pushes a hotfix or an asset update, it has to clear the cache across billions of nodes. If the update fails to sync perfectly, a residual file remains, a ghost asset from the previous version of the world. We laugh at the internet arguments over the spelling of a brand name or the death date of a politician. But consider the alternative. You aren't misremembering. You are carrying a fragment of data from a version of the reality engine that was quietly patched out while you slept. The system cleared the cache for the collective, but a few individual hard drives kept the backup. There is one final, deeper layer to this optimization: time itself. In multiplayer network architecture, when two clients have a mismatch in latency, the server forces a time sink. It artificially slows down or speeds up one player to match the master clock. Every human has experienced an acute crisis: a car accident, a fall, a sudden shock, where time suddenly dilates. Seconds stretch into minutes. You can see the individual rotation of a falling object. You can count the heartbeats. Neurology states that adrenaline forces the brain to record memories at a higher density, making the event seem longer after the fact. But what if the adjustment isn't internal? What if, during moments of high-density calculations, when your life hangs on a fraction of a millimeter, the system localizes its processing power on your coordinates? It drops the local simulation speed to calculate your physical collision matrix without crashing the surrounding environment. Our minds are designed to smooth over the rough edges of existence. We ignore the keys that vanish into thin air. We look away from the stranger pacing in a perfect mechanical loop. We accept the fog, the altered memories, and the elastic nature of time. We call it human nature. We call it coincidence. But these aren't errors in your perception. They are moments of efficiency. A system quietly managing its resources while you look the other way. The world doesn't need to render everything. It only needs to render what you are currently looking at. Right now, your brain is processing my voice. It is generating thoughts, looking at the screen, expecting a standard conclusion, a call to action, a subscription prompt. It expects the comforting routine of the internet. But what if this video isn't an essay? What if it's just a routine diagnostic? A localized script designed to check if your consciousness is still active, still responding to the loop. The test is over. You can close the tab now, before the system notices you've stayed in the empty room for too long.